This is chapter 4A again. So we'll just recover um, linear graphing because this is what I taught you last year, but I feel like some of you may have been confused a bit. But it's all right. I'm just making this video again. I'm just trying to make it a bit easier for you all. Okay. So we're going to be able to use table. We need to know how to use the linear rules. And then we're going to use graphs to show straight line patterns. Okay. That's all it is. So hopefully by the end of this video, you'll know parts of a Cartesian plane. You can understand that straight line graph shows graph shows a pattern. You can use rules to connect the variables x and y, make a table and draw a graph from that. Check if a point is on the graph and find where the line crosses the x-axis and y-axis. Another word for this is the find x and y intercepts. Okay. That's another way of phrasing it. All right. So, drawing a Cartesian plane. I gave you a sheet. You should stick it in your book. It literally tells you how to do it, but let's just reiterate it. So, step one, you want to draw two lines, one going from left to right. This will be your x axis, and one going from top to bottom, which is your y axis. Now, you must make sure that they cross each other so they overlap with each other. So, it'll look something like this. So, this will be your y, this will be your x. It will look something like that. Now, the next step is to label them with numbers. You must include both negatives and positive numbers. And this is what we call scaling. Very important. You need to do this, okay? Important. Now, step three, you don't really need to do it because we already know what it is already, but marking the origin. The origin is pretty much the place where they overlap, and this is called the origin, okay? That's all it is. All right, how to read and write a coordinate point. So this is what it looks like. This is what a coordinate point looks like. You must make sure you write it as X and then Y. Okay. So the first step is read the X value. On your graph, you'll be given a coordinate point. It'll be plotted. You need to know how to read it. So X is your horizontal axis. So read along the horizontal line, find where the point sort of sits, and then just mark it. You're done. Next step, read the Y value. So go up and down the y-axis, find where the point sort of lines up, mark it. Then you put it together as x, comma y. You have to do it like that, okay? Do not get mistaken for it. Now, I've already done it for you, but we can just talk it over really briefly, okay? So on the Cartesian plane, there are four different points. So if you have a look here, I have my points right here, okay? Just like that. So I have A, B, C, and D, and it's pretty obvious. So I'm just going to use a blue pen. So let's just start with point A. So I'm going to read along the horizontal. Okay. I sort of see that A lines up with the number 2. So I recognize it that the first number is going to be 2. And then I go up the y-axis or the vertical line. It sort of lines up where 3 is. So I know it's going to be the coordinate point 2, 3. Vice versa, if you go to the other points, it will be the same thing. So let's do point B. So let's just go across. So it stops at -3. Okay. Jot it down. And then we go up the y-axis. It stops at +2. So it's just like that. So you sort of get the idea. Okay. These slides will be updated on Google Classroom. Now, I just got to fix this before I move on. Otherwise, I'm in a whole heap of trouble. Okay. All right. What's a linear relationship? This is the definition. A linear relationship makes a straight line on a graph. That's all it is. And I'm going to use this example, 2x plus 1, to show that exact pattern. Now, how are you going to do that? You're going to create what we call a table of values, aka a TOV. Okay? This is how you would create your table of values. Just draw a nice box and add mini boxes into it, which is what I've done already. Now, something to note is my X is on the top and my y is on the bottom row. So x is on the first row, y is on the second row. That's all you have to do. Now, I am going to select some x values to substitute. Okay, that's the whole point here. Now, just to make your lives a bit easier, select x equals 0, 1, and 2. Those are the easiest numbers. Don't make your life too complicated. Okay, what I'm going to do next is substitute. So I'm just going to highlight substitute in a different color because you need to know how to do this. So I'm just going to write it separately. X equals 1, or x equals 0, I mean. What am I doing? So when I have x is equal to 0, I'm going to write out y is equal to 2. And I'm just going to put brackets in to act as my substitution. So I am replacing the letter x with the number 0 instead. Now, this is another way of saying 2 times 0, by the way. And obviously, we know what 2 times 0 is. It's 0. So 0 plus 1 equals to 1. That means whenever x is equals to 0 on this line, my y equals to 1, just like that. So I'm going to put y equals 1 where 0 is. And I'm going to do the same for x is equals to 1. Y equals 2, bracket 1, close brackets, plus 1. This is just 2 times 1. So this equals to 2 plus 1, which equals to 3. That means whenever x equals to 1, y equals to 3. Now, finally, we'll do x equals to 2. Let's get rid of that. That equals to 4 plus 1, which equals to 5. Just like that, okay? It's that easy. Now, once you reach this stage, okay, you should really transfer the info from your table values and write it as coordinate form. So as you can see here, I've written my 0, 1, like that, 1 and 3, 2 and 5. The final thing to do is just plot them, okay? Plot them. So where's 0, 1? So I'm going to read along the x. I know where 0 is. 0 is right here, and y equals 1 right here. So I'm just going to mark it like that. Then we're going to go to where 1 and 3 is. So 1, 3, and then 2, 5. Just like that. Once you've plotted it, just grab your ruler. Just grab your ruler, literally. Just grab your ruler and just draw a nice straight line. Oh, what's happening here? Obviously, when you draw it, your lines will be a lot more nicer than mine. But I'm just showing you this is what it looks like. Just like that. Okay? Now make sure you label your X and your Y axis just like this. Okay? It is that simple. That's all you do. You are done. Next, the X and the Y intercept. It's so easy. Just think of the word intercept. The word intercept means to cross. Okay? It's like, you know, when you're playing basketball and someone passes the ball, you are trying to stop that pass from going through. So you are intercepting it. You are stopping the ball from reaching its intended target. In this case, we have the X and the Y axis. Okay. So it's pretty easy. The Y intercept is just when line crosses the Y axis, and X intercept is when it crosses the X axis. Okay. I even have it here. This is literally it. If you just read that, it will make a whole lot of sense. Now, just to note, when the line crosses the x-intercept, the value of y equals to 0. Why is that the case? Well, if you just look at my diagram, it makes sense, yeah? This is at positive 2, this red line crosses the axis. What's my value of y in coordinate form? It's 2, 0, just like that. It's that easy. Now the y-intercept, it's when it crosses the y-axis. So we know the value is 4 in the y, positive 4. So what's the x value then? Just look at the graph. It's at 0. So it makes sense. So you're going to write 0, 4, where the y-intercept is. So you need to know how to do this. Now, if you're reading it from a table, it's the same thing. Just have a look. Just find, so when you want to find the x-intercept, just find when y equals to 0. So where does y equals to 0? At positive 2. Hence, that's the x-intercept right there. And then vice versa, you have the y-intercept. It's clear as day. Now over here, we just have some examples, okay? Write down the coordinates of the x and the y-intercept from the table value and the graph. Okay, so let's just look at the table values. It's pretty obvious. So x-intercept, it's when y equals to 0, yeah? So find it. So when does y equals to 0 in this table here? It's at this point right there, positive 1 and 0. So you're going to write 1, 0. So the y-intercept is when x equals to 0. So when does x equals to 0? Right here. So this is technically now your y-intercept. So 0. And what's the y value? 2. It's just like that. Not that difficult. Okay? So here, and you got here. That's it. Now, look at my lovely graph here. So we know the y value is positive 6. But what's the x value? It's just 0. Over here, I know my x value is negative 4 because that's how I read the coordinate form. It's read as xy. So negative 4. What's the y value? 0. Just like that. That easy. Now, finally, deciding if a coordinate point is on a line. Okay? Now, you can, this is just an example. It's not what you're actually going to get realistically, and it's not the same every single time. It just depends on what your linear relationship is. Now, once you have that, the question will say decide if coordinate something something sits on this line. Okay? What you're going to do is take the x value, substitute. I will retype this. That's fine. Just substitute the x value. Then work out the y value. That just means solve for y after substituting. Then finally, once you reach your final answer, you need to do this, comparing the y values. Very important. Now, if the y values match, great. That coordinate point sits on the line, or it is on the line. Now, if the y value is different, it just means the point is not on the line. Let's just do an example. Y equals 2x plus 1. What was our step? So we got step 1 out of the way. Step 2, take the x value. What's my x value in this case? I have x is equals to 4. Because remember, you read this as x and then y. Just like that. Let me rewrite that y. It looks ugly. Okay? So we know x is equals to 4. Now, substitute. Y equals to 2. 4 plus 1. So this is your substituting here. Then, you know that this just means 2 times 4. And 2 times 4 equals to 8. Plus 1. And 8 plus 1 equals to 9. Great. Now, compare. Uh, this is your evaluating stage. Compare. So we have 4, 9. That's what we want. And then we just check compared to our answer. Is it the same? The answer is yes. Okay, that's it. It works. Now, if what I figured out was a completely different number from what I wanted, you'll say no. It's that simple. All right, go through these questions, try it out, read the questions carefully, okay? Draw a table of values, draw your graphs. So uh, draw TOV and graph. That simple, okay? Enjoy.